Suppose somebody came with a cake, and then any other piece can be obtained by moving and maybe flipping your group operation. So now what that, if I start point here, dynamics does something. One of the slices. It does its magic in a full space. A land x times t, where that x times t in dynamics always tells me that that's unique. There is no doubt about it. You know, I start someplace, I end at someplace. And now there is another group element, which is if I take my initial point, which is in A, multiply by inverse of the final to go from one tile to another one. Now, if my law of nature is invariant under choice of tile, it takes the same shape in a full space, that can be written the action, which I call hat, where I replace x and y by their images. They're on a group orbit, so I just take their representative in fundamental tile. So the law of nature can just stay in this tile, just work in a symmetry reduced space, and all that we need to know about symmetry is a simple statement that says that the relative thing is obtained by pulling initial and final. And then we showed that when we take trace of that formula, so when we have to take a trace of this, we end up whatever happens in the fundamental domain. And that this thing is either zero or they're the same. So the statement seems totally empty. But the amazing thing that happens is that if I write it as a sum of irreducible representations, periodic in a fundamental domain, but they're running in the. So that's what we learn about discrete groups.